All right, so kicking off our next round of talks is Eric Bailey. Eric's been working on accessibility at GitHub. He put in a bunch of work over the years at the Accessibility Project, which is anybody familiar with the Accessibility Project? Yeah, if you're not, it's an absolutely phenomenal resource. Highly recommend checking it out. But he put in a lot of great work there. And this conversation, this topic, the intersection of performance and accessibility, is one of my personal favorites. We do talk a lot about the business impact of performance, and obviously that's important. That's what helps to open the wallets. You know, we talk a little bit about the SEO impact. That's another thing that has been like a big part of like opening up more and more people coming into the performance community. But the thing that has always excited me about web performance is how much it is tied to access and accessibility. And that human nature that like we're actually helping people when we do this is one of the most compelling parts about working in this industry, in my opinion. So let's give a round of applause for Eric, and hopefully we can close that Venn diagram a little bit here.
Yeah, wow, that's a heck of an intro. Thank you. So, hello, everyone. My name is Eric, and I'm a senior accessibility designer at GitHub. I live in Boston, Massachusetts, in the United States. Yeah. And I'm a tall white man with black hair and glasses. I'm wearing a short sleeve button-down shirt with a pink brain pattern on it because brains are cool and weird. And this is actually my first time in Amsterdam. So before I get into it, I just want to extend my appreciation here. Getting a chance to speak about accessibility outside of accessibility circles is a rare and wonderful opportunity. I'm thankful to the conference organizers for enabling this, and to you, the audience, for being receptive to it. There are a lot of parallels between the practices of performance and accessibility. Namely speaking, it's the practice of numbers going down and then telling people numbers go down is good. So I hope this talk will help to illustrate that. So with that all out of the way, let's set the stage here. This is a talk about performance, with performance being the mechanism in which something behaves. And with this context established, know that I'll be mainly talking about the behavior of the mechanisms that power assistive technology. So I was conducting an accessibility audit a few years ago, and if you're not familiar with what an accessibility audit is, know that it is the process of performing manual and automated checks to see if a digital experience can be operated by assistive technology. It's very similar to performance profiling and auditing, and honestly, equally as nerdy and detail-oriented. And for accessibility audits, you want to identify areas where there would be problems or straight-up barriers that would break assistive technology support, thereby preventing someone from being able to use your website or app. An example of assistive technology that could have its support disrupted would be a screen reader. If you're not familiar, a screen reader is specialized software that parses the contents of the screen, announces that content to the person using it, and lets them take action on it. And a button that someone is unable to press to save their progress because of how the button is coded is an example of an audit issue that affects a screen reader user. This is a case of accidental exclusion, where someone is prevented from being able to use functionality made available to others just by virtue of circumstance. The experience I was auditing was a medical education app used to train caregivers. It was built using a single-page application framework using Google's material design library to construct the interface. And when I learned that, I thought, Google made it. Oh, sweet. I don't have to worry as much. So I fire up VoiceOver, which is macOS's built-in screen reader, and I start testing. And things are going pretty well, and then VoiceOver crashes. It stops speaking. I try restarting Safari. I try clearing the cache. I try closing other tabs. Heck, I even try rebooting. Same result every time. So I ask my boss what's going on, and he says, "Oh, it's probably problems with the accessibility tree." The what now? So before I get more into this, here is a question for you. how do you describe an interface? I'm not saying, tell me what you hear or see when you turn the computer on. I'm saying, how do you speak computer to a computer to tell it what's present and what state it's in? One way we can do that is with the accessibility tree. Fundamentally, the accessibility tree is provided by the operating system. It is a running collection of objects, all the little atomic bits that make up a UI. Assistive technology makes use of the accessibility tree to read these objects, filter out the irrelevant details, and report on the remaining important objects to the user. Without a functioning accessibility tree, there is no way to describe the current state of what an interface is, and consequently no way for some people to be able to use a computer or a smartphone. So suffice it to say, this is a really important piece of technology. So then, how do you build an accessibility tree? How do we make all those little atomic bits of UI work? First, you have to give each individual interactive object a name, names being short identifiers used to describe purpose. Then you give it a role. Roles are predefined values that tell someone what they can do to the interface object. For example, a role of button means someone can press it to activate some sort of predefined action. Then we have properties, which are the attributes of the object. Examples of this are its position in the interface, its state, or interactions that are allowed. For our button, that could mean a toggle state to indicate it being pressed. Think here a play button on a media player. Finally, we have a description, which can provide further optional information about the object if needed. Put these all together, and voila, we have an accessible object. These accessible objects are then programmatically grouped together to form more complicated interface components. For example, our play button could be part of a larger media player, such as VLC, Spotify, or Apple Music. So then, how do you build these user interface components? Let's say an operating system alert dialog. That's a pretty commonplace thing for UI. Starting from the top down, we have a menu bar. That's the anchor that we're going to attach everything to. And then we add a title for the menu bar, so we know what it's all about and what contents we can expect to find. If you're using a screen reader, titles are really helpful, as it saves you from having to dig around inside the component to figure out what it's for. And if your product is a single-page application, it's also really helpful to update your title to reflect the purpose of the current view instead of just statically displaying the app's name. This is actually one of those circumstances where we actually don't want a more app-like experience on the web, and the web's platform default was a little bit better in this regard. Moving on, we might also need to close this dialog window once we learn what it's for, so we include a close button in the menu bar for quick access. Then we add the body of the dialog, the place where we can put the bulk of the dialog's content. In the dialog's body, there's another title, which asks us if we want to save the changes to the thing we were working on. And then we add text to the body, which will provide more information about what happens if you choose not to save. Then we add a save button, allowing us to commit to saving the changes we made, and an accompanying cancel button in case we don't. And presto, we have a dialog component. We can now speak computer to get what we want. This is because all these collected objects have accessible names and therefore are present in the accessibility tree. I can programmatically say, go to the dialog, then its body, and activate the save button. And it works. How cool is that? You might be thinking this feels a lot like traditional software tests, and yep, you're right. They're actually really close friends. Not as scary as it might seem at first. And this all might seem a little pedantic, but please bear with me for a bit. We do have this dialog component, yes, but there's more to it than just that. Interface components have to have a place to live, and that place is an operating system. Operating systems also include components that allow us to navigate to and access the stuff you store on them. It's also the place we install and run programs, and all the little doodads and widgets and clocks that we can't live without. And the browser, which is rapidly becoming an operating system in its own right. The browser contains the mechanisms we use to access the web. And the web is kind of like the Wild West in that you can write more or less whatever you want, and it'll usually work, which is honestly both a blessing and a curse. But regardless of how you write what you write, you can't escape the fact that you ultimately have to render HTML. That HTML then has its appearance and behavior augmented by both JavaScript and CSS. Again, there's many ways to go about doing this, but they are the other two requisite parts that make up the whole that is a contemporary website or web app. The HTML markup, augmented by both JavaScript and CSS, creates the document object model, or DOM tree, which is a programming interface for websites. I know y'all know this, but just stay with me for a moment here. Browsers then read the DOM and all the information contained within it to draw an interface, which is then shown to a user. The user can then take actions, which updates the DOM, which in turn updates what is visually rendered, and this allows us to make our websites dynamic. Running in parallel is the accessibility tree, which is sampled from the generated DOM. I say sampled because the accessibility tree will use specialized heuristics to only surface the things it deems necessary. Modern versions of the accessibility tree are generated after styles are computed, as certain CSS properties such as display and pseudo-element content will actually affect it. So when people tell you that CSS is only about presentation, yeah, it's the web, it's wiggly, it's not exactly true. Sorry you had to find out this way. Yeah, moving on. This sampled version of the DOM is then read by various kinds of assistive technology, including, but not limited to, screen readers. And there's two things I'd like to point out here. First, using a visually rendered interface and assistive technology aren't mutually exclusive things. It's a fact that not all screen reader users are blind, and many people choose to augment their browsing with various devices that are not screen readers that also rely on the accessibility tree. Secondly, the accessibility tree relies on the user interacting with the DOM to update. Accessibility trees are effectively a read-only technology in that we can't work directly with them, nor should we be able to. There's a few reasons for this, but the most important one is to preserve user privacy. Another thing you should be aware of is it's more of an accessibility forest than it is just a single accessibility tree. There are many different implementations of the accessibility tree out there. Each one depends on what operating system you're using and what version of said operating system is running. And this is due to the way different companies have built and updated their operating system's underlying code throughout the years. And just so we're clear here, the DOM can be a part of the accessibility tree, but the accessibility tree is larger and not just limited to the contents of your browser. Because of this, the accessibility tree is more brittle. It has more to pay attention to, and its core technical architecture was developed before this whole internet thing really took off. I still hear it's a passing fad, I don't know. So this means that it just really didn't anticipate the sheer amount of information we'd be throwing at it. Crashing the accessibility tree, and therefore breaking assistive technology support, is bad, yeah? But a large amount of information present in the DOM means that there's an accompanying large amount of work the accessibility tree needs to do to figure what's what and then report on it, which slows it down. This can create a lack of synchronization between the current state of the page and what is being reported to assistive technology, meaning that a user may not be working with an accurate model of the current screen. They might be taking action on interactive components that are no longer present or in a different state than they'd expect. This can create the confusing experience of users activating the wrong control, navigating to a place they didn't intend to, or unintentional data submission. Remember, some users here literally cannot see the screen and therefore have no indication that this desync is present. So how do we help prevent this? Start with writing semantic HTML. Yeah. Using things like the button element for buttons instead of aria slapped on a div helps lessen the amount of guesswork the accessibility tree has to do when it runs its heuristics to slot meaningful content into its description of the current state of the world. This serves to both speed up its calculation and makes what it reports more reliable. And speaking of semantic HTML, here's the raw living DOM of an actual website. In fact, it's the homepage for this conference. Even a static, performant website contains a lot of information a computer has to chew through. And again, utilizing semantic HTML helps reduce the effort it takes to generate the accessibility tree from the DOM's contents. And unfortunately, using semantic HTML is kind of a rare thing these days, which is partly why I'm here giving this talk. But also, fortunately, this site's semantics are really good. So big shout out here to Hitty and Krein for keeping it real. How about a quick round of applause, folks? Yeah, you love to see it. All right, I think you got the gist of it. Of this code I just showed you, 5 slides worth, we've only covered roughly half of one page. It's worth pointing out that this is a relatively short and simple page, and that, again, this is a lot of information to process. Keeping that DOM example in mind, we now have a simple form. It's a pair of unstyled radio buttons asking us if we want the chicken or the fish as our meal preference. And here's how that form might be translated into the accessibility tree. We have a parent field set element with a legend with a string of meal preference, 2 inputs, both with a type of radio, one with the name of chicken and one with the name of fish. The chicken input is checked as true state, and then below that there is a button with an accessible name of save. If we use semantic HTML, the names, roles, and properties are automatically filled in for us without any additional effort. And when I was speaking about how semantic HTML slots in, this is a more granular example of what I was getting at. And here's an even more granular example, sampled again from the conference homepage. It's a link for the schedule located in the website's primary navigation. I'm using Firefox's accessibility inspector to dig into this link's text node, and there's a ton more information being exposed, including attributes, states, actions, a child element count, relations, and available actions. All this data is used by the accessibility tree to help it describe the shape of things. And here's an even more high-fidelity example, a raw text dump of the accessibility tree for this same page. This is an example of what the language might look like when we're speaking machine directly to machine. We don't speak machine directly, though. Before we had Firefox's accessibility inspector, we had to rely on more specialized tools to be the translators. The Paciello Group's A-Viewer and Apple's accessibility inspector are the 2 go-to resources here. And you'll still need them if you want to inspect anything other than websites or roll up your sleeves and do some really serious digging. So with all that established, let's make the abstract immediate. What's going on here, and why should you care? With my auditing project, I narrowed the problem down to issues with material design's radio inputs. This is how these inputs appear visually. And here's how they appear in code. To make a material design radio input, you need 6 HTML elements containing 9 attributes with a DOM depth of 3. You also need 66 CSS selectors containing 141 properties, which weighs in at 10K when minified. You will also need 2,374 lines of JavaScript, which weighs in at 30K when minified. All this will get us a radio input. But you need more than one radio input to be able to use it properly, and oftentimes there's a few options to select from, and sometimes there's more than just a few options. And sometimes there's even more than that. And in the case of my audit, we had a massive amount of radio inputs being conditionally injected into the page. I can't really do much here. It's my job to bear witness and catalog access issues when acting as an accessibility auditor, which honestly is partly why I switched over to becoming an accessibility designer instead. The larger point being is that all of this adds up if you are not paying attention. Google's Lighthouse recommends an optimal website DOM tree has less than 1,500 nodes, a max depth of 32 nodes, and no parent node with more than 60 child nodes. What I'd like to call attention to is the max depth of 32 nodes bit. That might seem like a lot of wiggle room at first, but take a moment to think about the templates of the sites you've worked on. There's the frame set, wrapper divs, landmarks, component wrappers, and if you're doing it right, field sets on your forms, each digging a little bit more inward. Another part of accessibility auditing is providing suggested fixes for the problems you uncover. It's tough work, but nobody likes to pay people money to tell them all the things that are wrong, but then offer no solutions. If you know of a job that's like that, let me know. I'd love to switch careers. We wound up recommending a radio input pattern that utilized 3 HTML elements. It's a pattern developed by my friend Scott O'Hara, taken from his excellent A11y_styled_form_controls project. It's worth saying that Scott puts these patterns through their paces and tests them with an incredibly robust set of assistive technologies. So a nice side benefit is knowing I can recommend this project to others, say an audience full of performance-minded people, with a great deal of confidence. The updated radio inputs were completely visually indistinguishable from the updated version. And to compare the two solutions on the code layer, we have a 50% reduction in HTML elements, and we have cut the DOM depth down by a third. There's also a 30% reduction in CSS selectors and properties, resulting in the CSS payload of this component being reduced by 90%. We've also completely removed 30K of JavaScript, which is 30K less blocking resource being served. Cobbling up a rough prototype, we were able to create an environment that mimicked the conditions of the site we were auditing, only now using the new radio input code. And guess what? It worked. VoiceOver didn't crash. So why is this our problem? Why should we care about the fragility of other people's software? Well, prioritizing developer ergonomics without considering the generated HTML it produces can lead to bad things happening. And regardless of our setup, and despite our best protests, we tend to get even more things piled onto our base experience. Things like ads, analytics, social marketing engagement tools, development integration utilities, and accessibility overlays. If you are not familiar with what an accessibility overlay is, know this. They are predatory anti-solutions that prey on ignorance and fear of litigious action. By offering a one-line code solution that promises to fix all your accessibility issues, they all do this by enabling arbitrary third-party JavaScript execution on your product, which should hopefully already set off some alarm bells in the audience. And believe me when I say it's some of the worst front-end code I've seen in my entire career. Accessibility is one of the worst offenders in the market and has been repeatedly legally demonstrated to not deliver on what it promises, and in many cases actually create more access barriers. In fact, I've actually given expert witness testimony to this effect, so believe me when I tell you I know what I'm talking about here. Additionally, and really kind of squick, they refuse to comply with European Data Protection Impact Assessment requests, which is sus, to say the least. There's also, just to keep it light, there's the Cold War raging between websites and their users. An example of this is Facebook splitting a single word into 11 DOM elements in order to thwart ad blockers. And this graph, generated from the median values of how 1.3 million websites are generated, shows JavaScript claiming the majority of the share. This JavaScript majority means that it's that much more time spent blocking the browser from performing other actions, including things like interfacing with assistive technology. The point being here is that we oftentimes don't realize there are very real, very important things we sacrifice when we throw out what the browser gives us for free. Here's Marco Zahi, Mozilla's former senior accessibility QA engineer. This is what he has to say about all this. Quote, nibbling away at those milliseconds it takes for information to reach assistive technologies when requested. My current task is to reduce the number of accessible objects we create for HTML div elements. This is to reduce the size of the accessibility tree. This reduces the amount of data being transferred across a process boundary. Part of what makes Firefox accessibility slower on Windows, since Firefox Quantum, is that the assistive technologies now no longer have direct access to the original accessible tree of the document. A lot of it needs to be fetched across a process boundary, so the amount of data that needs to be fetched actually matters a lot now. Reducing that by filtering out objects we don't need is a good way to reduce the time it takes for information to reach assistive technologies. This is particularly true in dynamically updating environments like Gmail, Twitter, and Mastodon. My current patch, slated to land in early in the Firefox 67 cycle, shaves off about 10 to 20% of the time it takes for certain calls to return. And note that all this optimization is only for one browser, Firefox. And there are a lot of browsers out there. It's also not all about browsers either. This is a refreshable Braille display, one of the many other kinds of assistive technology. They are purpose-built, low-power, high-efficiency devices that many blind people use to read the web. Think of them kind of like Bluetooth speakers in the terms of how they connect to computers, smartphones, and tablets, and how much horsepower on average they have under the hood to use. Refreshable Braille displays also interface with the accessibility tree in order to physically spell out content. But as previously mentioned, I have far less computational power than a laptop or a smartphone. This means that they can be especially susceptible to failing to work when an experience is too non-performant. So, let's say I've successfully pled my case here, and, we hear, someone should do something, the battle cry of bystanders everywhere. Let's pragmatically unpack this some and figure out what our actual, real available options are. For screen readers, the main ones are JAWS and NVDA. Both are Windows screen readers. There's also VoiceOver for macOS and iOS, and TalkBack for Android. These are the big four screen readers you're going to hear about, and it's sort of analogous to Chrome, Safari, Edge, and Firefox in that there's more screen readers out there, but these cover the main use cases you're most likely to deal with. While not all assistive technologies are screen readers, if your site works well with them, chances are good it'll work well for other forms of assistive tech. Of them, all but one have an open issue tracker, but half have closed source code. This means that we can file issues. We aren't really empowered to do much about it on the assistive technology layer. I also personally think it's completely unrealistic here to expect people to submit and follow issues or code PRs across all trackers in addition to working a full-time job. We also don't know what's going to be prioritized and when. Remember, assistive technology has to pay attention to the whole operating system, so your website's current burning priority may not be the assistive technology manufacturers. And as the previous slide demonstrated, sometimes we also can't know what their own particular burning priorities are. Because of this, our only other realistic option is to keep the DOM trees on our sites nice and shallow and our JS payloads light. And there are actual tangible benefits to doing so. Here's Marco again, weighing in on his optimization efforts. Quote, reducing the number of milliseconds it takes for a screen reader to start speaking after a key press from about 140 to 100 here, or from 120 to 100 there, doesn't matter as much on a fast machine. On a slow machine, that reduction is from about 230 to 250 down to 200 or 190. So now, let's talk about what a slow machine means. If you are disabled and or underserved, you face significant barriers to entering and staying in the workforce. This means you may have less access to current technology, especially the more expensive, higher quality versions of it. Another factor is some people who rely on assistive technology are reluctant to upgrade their software for a very justified fear of breaking the one way they use to interact with the world. This includes the assistive technology they use, as well as the browser and the operating system it interfaces with. Slow machines may also not mean an ancient computer. Inexpensive Android smartphones are a common entry point for emerging markets and underserved communities, and with Android comes TalkBack. A slow machine might also be coming from a place you're not expecting, by which I mean you might have a state-of-the-art computer and are doing state-of-the-art things on it. This requires a ton of computational resources, which makes fast things slow. With less computational resources to go around, we may have unintended consequences, possibly recreating a situation similar to our too many radio inputs problem. Think Electron apps here, desktop programs that are built with web technologies. On the slide, we've got a few of the more popular ones out there, 1Password, Teams, Slack, Figma, VS Code, and Discord, many of which can be running concurrently. Accessibility auditing isn't something people normally do out of the goodness of their own heart. It's typically performed after a lawsuit has been levied against an organization. And let me be clear here, when you create inaccessible experiences, intentionally or not, you are practicing discrimination. The upcoming European Accessibility Act acknowledges this and will put protections in place starting next year to help ensure people cannot be discriminated against based off of their disability conditions. Similarly, the Americans with Disabilities Act already guarantees these protections. This extends to both private organizations and the digital space. And its language is couched in civil rights, which are some of the strongest protections individual citizens in the United States have. And this legislation is a good thing, as it guarantees protections as more and more of the services we need to live everyday life go online. You need to work with what you have and not what you hope will be. Part of this means understanding when we want things to be better, we need to understand that these kinds of changes are really technically complicated under the hood, as well as spread across multiple concerns, each with their own priorities, agendas, and resourcing. On top of that, accessibility fixes are often viewed as unglamorous and deprioritized compared to other features. I don't mean to bum you out, and I don't expect you to become accessibility experts. However, as people who are interested in more than just the surface level of things, you are all uniquely empowered to effect positive change. What I ask of you is to at least incorporate basic accessibility testing into your workflows. If anything, just check to see if a screen reader crashes when you're auditing a particularly gnarly performance issue. After all, a bad assistive technology experience is better than none at all. But Eric, you say, accessibility is scary, and I'm afraid I'll misrepresent something. Don't worry, friends. I'm going to teach you how to do what I did. If you're using a Mac, you can start VoiceOver by pressing Command F5. Don't do it right now, because it'll start speaking out loud, and you'll have everyone's attention on you. You then hit Tab to navigate by interactive item. And Shift plus Tab moves you backwards by interactive item if you're feeling particularly adventurous. You then tab around your website or your app. Did VoiceOver crash? If no, awesome, keep it up. If VoiceOver does crash, get to doing what you do best, advocating for and submitting PRs to reduce your JS payload and DOM depths. And don't forget, you can press Command F5 again to turn VoiceOver off when you're done, a lot easier than Vim, simple as that. Okay, whoa. The slide background color is yellow now. This is what I like to call a great segue. I'm a designer by trade. Part of that job means coming up with alternate strategies for allowing people to accomplish their goals. Because sometimes the most effective solution isn't necessarily the most direct one. With that in mind, we're going to talk about another definition of performance, which is the ability to actually accomplish something. All these little surgical tweaks and optimizations don't really mean squat if people don't understand how to operate the really fast thing you gave them. To that point, another part of dynamically injecting a ton of radio inputs into a page is that it adds more things for a person to carry in their head. This is called cognitive load, and it's a huge problem. It affects our ability to accomplish tasks, and importantly, our ability to accomplish tasks accurately. Namely, cognitive load inhibits our memory, problem-solving skills, attention, reading comprehension level, math comprehension level, and shockingly, our ability to visually process and therefore understand what we see. Cognitive load is such a problem that NASA developed the Task Load Index, an assessment tool to help quantify it. This isn't warm, fuzzy feelings about empathy. This is a serious attempt by a serious government agency to refine efficiencies and prevent errors. And one of the most interesting things about the existence of the index is that it's an indirect admission that disability can be conditional. I'd like you to all think about it. When's the last time you were using technology while tired, distracted, sick, or learning a new skill and the outcome wasn't what you desired? Heck, when's the last time you tried to use technology while drunk? Yeah, that Uber never showed up. Cognitive load is an important thing to track for building rockets, sure, but it also translates to other complicated things like making and using software. One of the things we can do to lessen cognitive load in software is to lessen the amount of information someone has to parse at any given moment. For the medical education app, we could have added an additional step into the user flow that asks a high-level segmenting question. It's a little bit more friction, sure, but it's being used strategically as a focused choice to keep the overall cognitive load lower for the subsequent parts of the user flow. This would help to filter down the results that you get, which makes it easier for both the person, or it makes it both easier for the user and the browser to parse. The other big picture question we need to ask is if all this work is even necessary. Hey. Hello. Okay, that was a boom. By which I mean the most performant page is the one you'll never have to use. How often can we sidestep these kinds of problems by using information and resources previously made available to us by the user? This is such an important thing that the Web Content Accessibility Guidelines has a rule for it. Success criterion 337, redundant entry, is level A, meaning it is a baseline requirement for all content on the web. It stipulates that you, as the provider of the experience, do not require someone to enter information that they have previously successfully submitted earlier in the experience. Not only is this good UX, but it's also helpful for people with cognitive and motor control disabilities. Like, observing this rule could quite literally save someone from experiencing unnecessary pain from filling out information that they have already submitted. So, be sure to keep this in mind the next time your company's shoddy reimbursement system makes you fill out the same info in triplicate before submitting, say if you're traveling for a conference and, got a ride from the airport. If you're interested in this sort of thing, the 2018 Design and Tech report is a much-read piece. One of the surprising things it revealed was that very few companies conduct qualitative user research, which is the practice of asking people how they use a feature and then how they'd feel while doing so. So 12% of early-stage startups, 32% of mid-range startups, and 46% of late-range startups don't do qualitative user testing. That's sub 50% for each category of startup listed. Yikes. I'm not a numbers person. A lot of people here are, and that's cool. Not for me. But there does seem to be a trend to me going on here, and it's not a great one. Another interesting thing is barely any companies conduct qualitative user testing after launching their features, even if they do perform qualitative user testing beforehand. So we're all just collectively throwing features and the piles of code that these features require into the ever-evolving ecosystems that are our products, and then not checking in to see how they actually affect things. We also need to remember that we're only seeing those companies that beat the odds. The market is built on top of the corpses of failed businesses who poured all their cash and resources into the wrong strategies and features. When we parrot these perceived successes at our own places of work, know that these successes are largely coming from sheer probabilistic luck. If you need a more concrete example, consider Evernote. An app that started out as an industry darling is now mainly talked about in terms of concern for what will happen to note content when the company inevitably folds. This stems from decades of mismanaged strategy, redesigns that didn't meet the mark, and features that failed to meet product market fit. Oh boy. we should all strive to do the opposite here. We should make it fast. We should make it accessible. We should make it easy to use. We should make its value apparent, and then ask people what they think of it, and continue to ask them what they think of it as time goes on. So, in wrapping up this talk, I have 3 requests. Very selfish of me, I know. First, let's all break down these isolated islands of siloed practice. It's a dirty little secret that the bulk of accessibility issues are created in the design phase. And I'd wager the same is true for performance. As performance-minded engineers, we can collaborate earlier with designers and plead our cases in a way that they'll actually be willing to respond to. One such way is to proactively identify potential bottlenecks where a redesigned user flow can cut the performance Gordian knot. Remember, at its heart, performance is user experience, and sometimes the most impact happens before the development layer. The second ask of me is carrying the torch from a talk from an earlier iteration of this conference. There's a 4-year-old issue on GitHub from Scott, asking about taking the spirit of what this talk drives at and incorporating it into Lighthouse. We all know that Lighthouse is an incredibly influential tool, and I'd like to point out that there are a ton of incredibly smart, influential, and dare I say, friendly-looking people here today. And a little renewed attention on this issue could do a lot of good. The third big ask is acknowledging that it's one thing to read about something and to know it to be true. But it's another thing entirely to put it out into the world without verifying that it works. Shout out here to Tammy's wonderful morning keynote, where she encourages us to get comfortable with being uncomfortable. So, in the spirit of that, why not experiment with incorporating basic accessibility technology checks into your performance audits? The web, and more importantly, the people who use it, are too vital not to. Thank you for your time and for your attention, and thank you to Performance.now and its organizers and staff for this opportunity. My contact information is available on my website, which is ericwbailey.website, and I'm on Blue Sky and Mastodon these days. I'm also terminally online, so please feel free to reach out anytime. Accessibility is a bit of a gnarled mess, and if I can help you navigate that maze, to mix my metaphors, I'd love to help you do it. And thank you again.
Thanks, Eric. That was great. And as somebody who judges the quality of my jokes at home on if I can elicit groans and rolled eyes from my kids, I really appreciated the segue comment.
Yeah, thank you. Yeah. Sometimes you just start with a slide and then work backwards from there, and that's
I hear you. Yeah, I don't know about you, but that's usually the slides that creep into my talk when I edit late at night, and I don't listen to that voice that says don't do that anymore.
Yeah, all the good choices happen late at night.
That was great. So, there's a number of questions. We're going to get to some of the metric measurement. I'm glad you brought that up. That issue's been sitting there for a hot minute, and I feel like that's been a topic of conversation for years of trying to get there. But first, I want to take a step back and just, starting from square one on this, we talk a lot in performance about advocating for why we need to be investing as a company in performance. And with performance, there's WPO stats. There's a fair number of case studies out there at the point where we can say, hey, X percent leads to X amount of, X improvement leads to X percent of revenue or conversion or whatever it is. That helps. The SEO carrot helps. And that's really a massive thing. If somebody wants to go back and be like, hey, for our company, we should be doing this. We need to be testing, our accessibility. We need to be actively working on it and improving it. How do you get past that ROI conversation?
Yeah, that's a great and terrifying question. So I kind of want to shout out to Harry's talk before mine, and something that he touched on is you kind of got to be everything to everybody, which is I think in the field of accessibility, there's historically been people coming in thinking that they're on the sides of the angels, and just by virtue of proclaiming, it must be accessible because it needs to be, therefore I'm righteous. Like, that doesn't really work. And like, my consulting background kind of taught me that, like, you need to figure out what the motivational strategies of the people that you're working with are. And so some people are motivated by the ethical angle. Some people are motivated by, honestly, law and legal. Some people are motivated by like appeals to quality. It depends on who you're working with. And one thing that we've been doing at GitHub, we just invested a lot of resources into remediating Primer, which is our design system. And the cool bit here is we have concrete numbers to kind of show that this redesign, re-engineered approach to some of these components have tangible benefits on speed to close issues, increasing like development speed and velocity, and like really good stuff. So like, they're indirect metrics in that they're not necessarily tied to accessibility, but same thing as performance, it's all holistic. So just pay attention to what's out there, what people care about, and then kind of plan your angle of attack that way.
That's awesome. Is there any chance, as a numbers person, is there any chance that data or those metrics are ever going to like become public in any way or like written about a little bit? I'd be curious to hear more about that at some point.
Yeah, I'd love to. Stay tuned.
Yeah, okay.
Yeah.
Cool. Okay, so then getting to, some of the metric-y kind of things. All right, so one question, you were talking about how the accessibility tree is dependent on the DOM. And so it got me thinking about like, we measure things like interaction in XPaint, right, as like a measure of interactivity. So basically, I click, and how long does it take from the click to when I get like the DOM update, everything else that has to happen, and then the paint occurs on the page. And obviously we know that that's problematic. We've talked about like the conversion in one of the earlier talks and stuff. What I'm thinking about there is like, what happens to the accessibility tree in that situation? Like if I'm somebody using assistive technology and I interact with the page, and let's say that it is a 600 millisecond IMP, and so it takes that long for that work to complete. Is there immediate feedback and affordances like right away when you interact with the element that tells people like, hey, this is doing something, and then you're waiting for half a second? Like, what does that feel like if you're using assistive tech?
You're gonna hate me. It depends. It depends on the operating system, it depends on the device and its horsepower, it depends on the AT and its version, it depends on the browser pairing you're using. More often than not, it won't announce anything, or the way a screen reader will interact with the A-tree is it'll actually create a buffer. So your announcements may be queued up in that case where like you kind of have the initial render and then like it chokes out for a little bit and then it resumes. There might be enough information for it to read through in that middle period that you don't even know anything is happening. It might just stall out. It's sort of like one of those things that's hard to really predict, but also like the bar is in hell, so a lot of people are just used to, waiting for like a quarter of a second for things to instantiate.
Well, that's the other thing that was kind of interesting is you mentioned, Marco was talking about like, on slow devices taking it from 250, 200 or whatever milliseconds. And I remember a presentation from, his first name is Kevin. I can't remember the last name, unfortunately, but it's been a long time. I'm getting old. But he gave a talk about, using assistive technology, and he talked about, particularly in this situation, he was blind, so he's a blind user, and he was talking about the Kindle and how you have a playback speed. And he played it on max speed. And everybody in the audience were like, I have no idea what's happening right now. This is just blowing by too fast. And he brought up that the blind community had advocated to Amazon, like, we need faster playback, because to them, it was too slow. And so that made me think about this like 200 to 250 milliseconds, which we know we try to avoid in general. Is there something to that? Like, are those delays more significantly felt? I know you said that they're kind of like, unfortunately, maybe they've learned to just be patient and have to deal with it, but it feels like that would be a significant barrier. Yeah,
I mean, like, the cool thing here, or the like warm fuzzies, is humans are humans, and like that millisecond barrier is just felt universally. Like, we know those are really small periods of time, but like, when you're just staring at a screen waiting for something to happen, it can feel like an eternity. So that's like definitely a really real phenomenon. The other, just to nerd snipe you about digital voices, like if you want to talk performance and you want to go real deep, there's actually like UX to virtualized voices where some of the voices are designed to be read at like 500 words per minute. And that's because like for people that are used to hearing the web announced like that, it actually makes a lot more sense where like more traditional, regular, normal human speaking voices like this, they get all smushed together and like it just kind of sounds smeary. So like it's performance in a really weird niche way, and I love it.
Yeah, that's I do love those little nerd snipey rat holes.
Gotcha.
On the metric side, I'm going to avoid that. On the metric side, so that the Lighthouse issue, I do encourage anybody who hasn't looked at that before to look at that. I think the primary thing was around the accessibility tree and when it gets ready. But is there any like momentum on that, or like potentially being able to tell when screen readers like crash? Like that feels like another thing we'd love to have reporting on.
Yeah, that's a really good question. I'm not sure. Like they collect internal events and phone home if you set them to. I'd love like the real dirty little secret of a lot of accessibility stuff is it's not complicated. It's just been not paid attention to and underfunded for decades. And so like a lot of this stuff, contemporary software has already figured out. We're just kind of waiting to catch up. So yeah, would love for y'all to look at that issue.
All right, yeah, please do. All right, thanks, Eric.